What's a discovery that could rewrite science overnight? Story 1. Where I live, there are theories about Polynesian traces in Antarctica. There are Maori oral traditions that describe something very similar. Multiple Maori histories, including those preserved by the Ngati Raura and Te Ati Awa Iwi, tell of an explorer named Hui Te Rangiora who led a vessel called Te Iwi Oatea to a place described as foggy, misty, and dark, unseen by the sun. The stories mention towering peaks that pierce the sky, but are completely barren and lifeless, beyond what sound like clear descriptions of Antarctic icebergs. These accounts also reference marine mammals, which strengthens the argument that these weren't just symbolic myths, but descriptions of a real place far south. Story 2. This one is highly speculative, but it's something I absolutely refuse to dismiss because of how mind-bending it is. The idea that myths surrounding the Pleiades are actually part of a continuous story humanity has been telling since we first left Africa might be the wildest possibility I've encountered. If true, it would mean certain stories have survived tens of thousands of years across migrations and cultures. The implication would be deeply existential, something like discovering we exist solely to serve another intelligence, similar to Hitchhiker's Guide to the Galaxy, where humans are biological computers, or a Matrix-style reality where our existence serves a higher, unseen purpose. Story 3. Aliens are easily the craziest, but still possible, discovery humanity could ever make while remaining within known physics. There's no evidence yet, and it may be extremely unlikely. But if it happened, it would fundamentally change everything. Imagine aliens arriving and revealing they've been observing us for thousands of years. Then they show us ultra-high-resolution footage of every major historical moment. Ancient Rome? Here it is. The crucifixion? Multiple angles.
JFK? Clear footage.
A selfie during the construction of the pyramids. Our understanding of history would be completely transformed and deeply humanized. Story 4. One of the most realistic discoveries that could rewrite history would be conclusive proof of pre-Viking contact with the Americas. Many ideas about Roman or large-scale transatlantic trade are likely outside accepted history, but small-scale exploration or contact, whether from Europe, Asia, or especially Polynesia, seems far more plausible. Evidence of even limited contact would radically change how we understand global exploration and early human movement. Story 5. Finding proof that hominids other than Homo sapiens used advanced construction, mathematics, or complex multi-step processes would be world-shattering. We already know Neanderthals arranged broken stalactites into circles, and made sophisticated tools like spears and axes, likely hafted. We infer intelligence from skulls, hands, genetics, and cave remains. But discovering something unmistakably structural, precise construction, symbolic writing, clear language systems, long-distance trade, adhesives like fish glue, anything requiring planning and abstraction would make it impossible to continue dismissing them as primitive or animal-like. Story 6. The ability to engineer proteins that can be injected into the brain to create false but fully authentic memories would change everything about reality. Could we program religious experiences? What would that mean for faith? What about implanting false testimony, or giving someone memories of events that never occurred, even pleasant experiences that didn't actually happen? Alongside that, there's the idea of digitizing a human brain, or looping back from binary computing to lab-grown brains that interface directly with digital systems. And finally, what if we conclusively determine that people with multiple personalities are genuinely separate conscious entities deserving of rights? They pass tests of awareness and understanding. They exist, even if briefly, and aren't we all temporary in our own way? Story 7. The discovery of a new Mesoamerican codex containing substantial, previously unknown information would be enormous. Every few decades, new codices are rediscovered, but most date to the early colonial period and don't add much new information. Still, it's possible that one day we'll find a document that significantly clarifies political relationships between city-states during a specific era, something comparable to the Mixtec codices, which gave us detailed biographies of rulers like 8 Deer and 6 Monkey, fundamentally reshaping our understanding of Mixteca Alta history. Story 8. Imagine a well-preserved boat or ship discovered buried high on a mountain, say somewhere in Turkey. Assume it's over 3,000 years old. There are dozens of reasonable explanations: ceremonial burial, ritual use, elite tombs, offerings. Perhaps someone was buried with household items and sacrificial animals alongside the vessel. Despite all that, it would instantly become known as Noah's Ark or Noah's Tomb. It would turn into a massive global pilgrimage site, similar to religious locations in Jerusalem. People already go wild over vaguely ship-shaped rocks. This would be absolute chaos. Whether it had anything to do with Noah or a flood would be completely irrelevant to the reaction. Story 9. Some of us believe matter and antimatter already exist within the layers of black holes, since antimatter is simply matter arranged differently. When combined, these forces could be responsible for the creation of galaxies, or even universes, from black holes. Others think there may be endless versions of these structures within an infinite sea of energy. When these components interact, they trigger cascading implosions and expansions, possibly occurring faster than the speed of light. Just a theoretical opinion, yes, and it was banned by theoretical physics. Story 10. It would be incredible if we discovered that civilization didn't originate in or around the Fertile Crescent at all. Instead, imagine uncovering solid archaeological evidence showing that agriculture, animal domestication, and early cities first emerged in sub-Saharan Africa, East Asia, or Southeast Asia. I'm not claiming this is the case, only that a discovery like that would completely upend long-held assumptions and force a massive reevaluation of human history. Story 11. A source of free or near-free electric energy. Food, no more problem, since light and temperature could be controlled. Food could be grown in massive towers by artificial light. Life in deserts? No problem. Transforming salt water to drinkable water isn't super expensive anymore, and air conditioning is no big deal as well. Also, huge underground cities wouldn't be a problem. Memes, so much more space. It would lead to a similar massive population growth as in the first agricultural revolution. Food, space, climate, no problem anymore. On a more dystopic view, one could say that poor people will live underground and places above could become a playground for the rich. Story 12. Scientists theorize that dark energy and dark matter abound in the universe, but cannot currently be detected by us. What's more, if it exists, it comprises the majority of the universe. There is more of that than there is of the energy and matter we know about. The breakthrough discovery would be to find ways of detecting this stuff as easily as we can our own universe, with telescopes, etc., and realizing that there is another universe complete with galaxies, stars, and planets alongside ours that may well have life in abundance. Furthermore, since it coexists with our own universe, there may be dark planets nearby, or even intersecting with our own. Such worlds would be reachable since we would not be limited by unreachable distances and speeds, as we are on our own. Story 13. The discovery of quantum consciousness transfer, QCT. Scientists have unlocked the secret of transferring human consciousness between bodies using quantum technology. It's a groundbreaking discovery that would have profound implications for society. Here's how it might work. Quantum consciousness transfer, QCT, involves mapping the entirety of a person's consciousness onto a quantum computer. This quantum consciousness data is stored securely. It's then possible to transfer this consciousness data to another human or synthetic body, essentially allowing a person to jump from one body to another. This technology could be used for medical purposes, such as transferring the consciousness of a terminally ill person into a healthy body. It could also be used for life extension, allowing individuals to switch bodies as they age. However, like any powerful technology, it comes with ethical and societal challenges. Questions about identity, consent, and potential misuse would need to be addressed. The discovery of quantum consciousness transfer could revolutionize the medical field, lead to remarkable breakthroughs in human lifespan extension, and fundamentally alter our understanding of life and identity. Story 14. I honestly think we have most of the framework that we need to actually accomplish anything we want. We're just currently suffering a temporary transitional economic structure that leaves a few people very powerful and encourages isolation among the rest. I'm sure there is some paradigm shift in the future, but really, we just need to start working together and building large-scale green infrastructure. I guess a more serious answer would be if someone mathematically proved that microeconomics is the load of crap that it actually is, and for us to start focusing on macroeconomics as a society. Story 15. A blockchain internet with 4 copies, not hundreds, so that all information is protected and secure. Also, the internet is built on gatekeepered collectives so that nations cannot interfere in each other's elections. All social media apps are created open source to remove the monopoly of the social media corporations that now decide what we think and what we should buy. A blockchain internet to ensure we own our own data and we decide who we can loan it to. And a blockchain internet that signs all created media to preserve ownership and remuneration, and ensure an accurate and truthful media. And a blockchain internet to uniquely identify all AI so they can be regulated and given equal rights. Story 16. P equals NP. This is a problem in computer science that equates the complexity of verifying a solution to the complexity of actually coming up with the solution. Most people think it is false, but it has not been proven to be false, which means we have not yet found a single counterexample. If someone were to provide a constructive proof that it is true, the work involved in that proof would likely result in a massive windfall of computational problem-solving breakthroughs. A lot of applied mathematicians work with mathematical models that remove a lot of the complexity from the actual situation in order to make decisions about how to manage a problem. Many of these problems are the kinds that proving P equals NP could lead us to be able to solve completely, as opposed to using heuristics. On the other hand, it would be disastrous for digital security. The entire concept of cryptography is built around the idea that these problems are prohibitively difficult to solve, but that could stop being the case with these hypothetical techniques resulting from a proof. Story 17, Ghosts. Paranormal believers never think about the implications of ghosts being real. If any of the millions of haunted houses actually had a ghost, the entire world's militaries, governments, and venture capitalists would be there in an instant. Defining a force that allowed essentially quantum non-local communication and interdimensional transport would completely change the world. Story 18. Why the value of the fine structure constant is what it is. Better yet, proving that its value has no meaning or origin, it simply is. Okay, so not going to shock the masses. Agreed, but profound, I think. Proof that abiogenesis is chemically straightforward, inevitable, and that it must, in fact, occur often and quickly in chemical environments that are quite common. Proof that the entirety of human behavior is 100% deterministic and predictable, to an arbitrary level of specificity and accuracy. Proof that we have not discovered intelligent life yet, not even here on Earth. Discovery and widespread acceptance that 99.9% of the human condition is utter nonsense. I'm talking monkeys with typewriters here. Discovery that the human species is the paperclip maximizer. Widespread realization that current artificial intelligence isn't, and that our efforts in pursuit of it, such as linking more and more fancy calculators together and expecting that consciousness will magically arise, reflects our inability, or perhaps mere failure, to understand what it means to understand something. Story 19. If we found some kind of spiritual force that acts between believers and what they believe in, physical forces like gravity and electromagnetism can only be seen due to uncountable years of research and experiments and measurements, calculations, and predictions, and nowadays are very logical to us. What if we found out that there was a measurable interaction between believers and what they believe in, whether it is nature or any gods, some kind of energy that is transferred from the mind to the environment? What if, after another decades of research, we would figure out that you can actually move mountains by belief, mediated by the spiritual force? That would also make any god measurably real, only if enough people truly believe in them. This would completely change our view and understanding of the universe. Hope you guys like this idea as much as I do. Story 20. Some thoughts. Perpetual motion machine, that should be impossible in our universe. Superconductor at room temperature, which might even be possible and may be discovered during our lifetime. Fundamental physical constants aren't constants. There are 26 physical constants that define the shape and rules of our universe. What if we discovered that they aren't the same in all regions of our universe, or we can manipulate them? Nuclear pasta can be made by mankind. Nuclear pasta is an exotic state of matter where matter is bound not by the weak nuclear force, but by a strong nuclear force. It only forms in a supernova or neutron star. This material would be multiple magnitudes stronger than every material we know. Story 21. Doubt fundamental physics will ever be overthrown. In 400 years or so, I don't know of a case of it happening. Things end up as special cases of other things, which generally means anything related to existing applications also doesn't really change, and the deeper understanding generally relates to entirely new knowledge. Closest examples I can think of to known physics being proven wrong are the nature of light, which was really the realization that both competing models are right and created certainty from ambiguous and undefined behavior, and the nuclear forces, which could be seen as unending established knowledge but in reality only extended our knowledge down the size scale. Even if light speed violation was found, it'd only be under practically impossible to engineer circumstances at the extremes somewhere. You've also got the problem that there is absolutely nothing known that needs explaining that seems to challenge that law in any way. Dark matter is the poster boy of this. Exotic, unknown, catches the imagination, and likely extremely challenging to detect even after the Nobel Prizes are handed out, much less turn into technology when the only scale it appears to have any noticeable effect on is galactic and above. Story 22. In 1887, a couple of scientists tried to measure the speed of light in different directions to see which way we were moving. They set up a granite table floating on Mercury, and reflected light back and forth in different directions and found that there were no changes. There were two possible explanations. A, the universe revolves around Cleveland, or B, the speed of light never changes even if you are moving. They quickly decided that A was unlikely, and that led to relativity. Story 23, there is a classic scientific method example you can watch on a Nova rerun. In the late 1960s, there were two main theories about how the moon was formed. It could have been formed elsewhere in gravitationally capture theory, or it could have been formed connected to the Earth and then it separated, fission theory. A bunch of scientists from each camp were interviewed before the moon landings. All of them said, if you go to the moon and run these tests, we will know which one is right. Then we went to the moon and ran the test. The capture theory guys pointed to some of the tests and said that this disproves the fission theory. The fission theory guys pointed to some of the other tests and said that this disproves the capture theory. Both groups made very strong arguments, but the issue was not really resolved. Then a new theory came along. This theory was that a large protoplanet named Theia smashed into the Earth soon after it was formed. Impact theory. The cores of both of these objects settled into the Earth's core. Some of the outer layers stuck to the Earth, and some of it splashed into orbit. The splash started sticking together by gravity and formed the moon. The impact theory is widely accepted today, although some people think there might have been more than one impact. I consider this science working at its best. Here is a great article about it. Story 24. Laws of science are descriptions of how reality works. They have clear limitations stemming from multiple reasons, such as limited amount of data, necessity to simplify our models in order for it to be remotely useful, explicit or implicit assumptions that go into the model that can be only approximately justified or justified only within some range of conditions. So as such, they are limited. Saying, y is impossible according to the law X means that y is impossible as long as assumptions that went into the law Y hold true, and as long as simplifications and/or extrapolations that were made are justified. It's impossible for a solid piece of metal to flow, but change the conditions and all the laws that we have for solid metals are no longer valid, they are no longer solid and flow just fine. The speed of light limitation comes from general relativity, but we know for certain that general relativity has its limitations. Who knows what we will find once we explore a reality outside of conditions under which GR is valid. 25. Scientific laws are typically conclusions based on repeated scientific experiments and observations over many years and which have become accepted universally within the scientific community. I copied that, but the definition stands. In physics, I would say the law of science has not been overturned in any way where the impossible has become possible per se. There were assumptions that have been incorrect but were not taken as laws of science at that time, i.e., at one time there was no consideration of a universal speed limit, for example. More so, universal laws of science are a relatively new concept in the last few hundred years. Prior, there were a lot of theories, many correct, but few ways to experimentally test. There are actually not that many to even consider to this day. Conservation of energy, conservation of mass, universal speed limits, and a few others. It is unlikely they will be overturned. But if they were, it would be an understatement to say it would be huge news, and we would likely have to reconsider reality as we understand it. Within the other sciences, the laws of science are not as fundamental as they are in physics. There are some that say we will never be able to interface directly with the human brain, for example. And while that may be true, this is more a problem of engineering. No one really considers that a law. Story 26, I think you could argue Newtonian physics. All those laws of physics based on the Principia you memorized in school were all negated by Einstein's relativity. Why? Because their use is almost universally accurate, except in some complex systems where their predictive power breaks down. Something that is supposed to be universally true cannot have instances where it is false. At some point, only equations based on relativity remain accurate. Story 27. There's a terrific example of this that is referred to as the black swan theory. There was an old Roman saying about as rare as a black swan, i.e., impossible. This found its way into formal European texts about formal logic as an example of something that is inherently wrong, i.e., a black swan. Therefore, there was something of a surprise when Dutch explorers found swans in Australia that were, in fact, black. This meant that all those little textbooks of formal logic that included problems, statements based on the fact that all swans are white, were now officially wrong. Hilarious. Story 28. Yes, the Rutherford experiment. Rutherford gold foil experiment was used to understand the structure of the atom. Rutherford and his students fired positively charged alpha particles through cold foil surrounded by a tube with a phosphorescent screen used to detect where the alpha particles ended up. The model of the atom prior to Rutherford suggested that the alpha particles should almost entirely go straight through the foil. However, the results showed that the alpha particles were also scattered by the foil. Rutherford's results concluded that atoms must have a large positively charged nucleus at their center, and also that atoms are mostly empty space. They expected a different result from what they got, and discovered atoms were not what they thought. Story 29. I think dark energy is a big one. We know galaxies are moving away from us, and we worked that backwards to conclude that everything started in one spot and exploded outwards. Logically, the gravity of everything pulling against everything would very slightly slow that expansion down, and eventually the galaxies would stop expanding and behind contracting again. Until the early 90s, this was the projected fate of the universe, an eventual big crunch when all matter collapses back to a single point. But then better data showed that actually, rather than slowing down, distant galaxies are moving away faster. Something is accelerating the expansion of the universe and overcoming the force of gravity that should be slowing it down. We called this phenomenon dark energy. There was a point in the middle when a lot of scientists didn't believe it and thought it was a mistake in the measurements, until more data showed it wasn't a mistake, and there really was a fundamental shift in our understanding of the universe. Story 30. 19th century scientists argued that knowing the chemical makeup of stars and other planets was simply impossible due to Einstein argued splitting the atom deliberately was impossible in 1934, and Kelvin was arguing heavier than air flight wasn't achievable right until the Wright brothers did it. Black holes, warm superconductors, it's often hard to tell which laws are fundamental and which are not. That being said, FTL prohibition is a big one. It seems entirely solid, and anything that violated it would be completely paradigm altering. Story 31. Where do you think all of our current laws of science came from? BTW, this is why science has no laws. The sciences have laws, but these are all subject to change as we discover more. We will never exceed the speed of light by relying on EM field propagation, because EM field propagation occurs at the speed of light as a matter of definition. Currently, we don't have any other reliable ways to manipulate anything or continue existing, other than through EM fields. So this makes it almost a matter of logical tautology that we cannot exceed the speed of light as long as we rely on EM fields. But we're pretty sure that a rather large portion of the universe doesn't rely on EM fields. That doesn't mean we'll figure out how to exist or act without them anytime soon, but it does mean that we can't exclude the possibility completely. A lot of scientists have bet a lot of time, money, and effort on that possibility. Are they necessarily right? No, but they're not necessarily wrong either. Fun fact, we currently have evidence that the rate of propagation of gravitational fields is similar to the speed of light, but we don't have any proof that they are necessarily the same, and most of our current theories of physics start to break down rather badly if we insist that they can never be different. That's not proof that they are ever different, just evidence that we don't firmly understand physics well enough to make it work consistently if they're not ever different. And it's far from proof that we'll learn to manipulate gravity or any other fundamental forces without relying on EM fields. It's just something to keep in mind. Story 32. Self-replicating life forms without cells. A cell is already an advanced form of life, and logic dictates that it must have evolved from something that didn't have a cell wall yet. There's really no good reason to assume that these pre-cellular life forms have disappeared. We just haven't noticed them or looked for them. They may be everywhere and maybe even outnumber cellular life. The most compelling hypothesis I've read posits that protocells with primitive cell walls likely evolved in porous microenvironments such as those found on the seafloor, that is, specific types of cooler, longer-lasting hydrothermal vents. The pores acted as protected membranous substrates through which lasting electrochemical gradients could establish and maintain themselves. All of the ingredients needed for cellular life were present. Things like cell walls and a proton motive force therefore could be the living extrapolations of what began as run-of-the-mill geological and geochemical features we predict are widespread throughout the cosmos. If true, it's possible there are, to this day, active vents hosting this most basic form of pre-life life or living processes on this planet's seafloor. There's something beautiful about this theory and others like it, for me because it argues, strongly, that life is a fundamental byproduct of basic chemistry if given the right conditions. It's no more mysterious than cloud formation or volcanism, and it's why, eventually, we'll be scouring the seabeds of other planets in the hopes of finding life. Story 33. Hard to think of something as significant as you're asking for. Kinda by definition, it seems very unlikely, meaning all answers are going to seem probably wrong. Possibly finding evidence of a dead-end species very similar to humans that did not survive. Why did that species not survive if they had similar brain communication as we do? we might need to rethink the environmental pressures that allowed us to survive. Maybe finding evidence of a virus that had a significant impact genetically. Learning we had very different immune systems 50,000 years ago. Learning of some gene that has evolved a lot recently. Story 34, a bit less scientific in nature and more on industry and engineering, but I hope for the industrial production of graphene and various useful metamaterials for commercial use. Material sciences in general have been turning out some exciting discoveries, but most of them will stay on paper until they can be reasonably produced. In a similar vein, I'm really hoping for a warm temperature a convenient and stable superconductor that doesn't need to be cooled to a few Kelvin above zero would be immensely useful. Story 35, cosmology, in particular observational cosmology, will continue to blossom and will likely be the arena where high-energy physics will find empirical validation in the far future. Gone is the era of the particle accelerator. Though I'm biased, in particular, LISA is scheduled to launch in 2034, so we will probably get a breakthrough in 2040-2050. LISA is a gravitational wave detector like LIGO, except it's a satellite in space. It will give so much astrophysical data about our galaxy that astronomers will not be able to prevent jizzing in their pants. It can measure cosmological parameters like the Hubble constant without using the distance ladder or the cosmic microwave background. And it's sensitive to the gravitational wave background from sources such as inflation and or beyond the standard model physics.